Welcome back, and now you're going to see an example that is quite long, and these are kind of the average types of problems you're going to see. So the idea is that you want to do a bunch of analysis on this on this function you see below, and we've been working with it in many of the videos, but we're going to do a lot of analysis to obtain a sketch of the graph. Okay, so we're pretending that Desmos and other graphing utilities don't exist for a moment, well, for a while, and we're just going to do a bunch of analysis and get a picture of what the graph looks like for the most part. Okay, so it says identify the roots. Okay, so I'm just going to do this kind of stepwise. So identify roots, that would be where f of x is equal to 0. And so I'm going to skip that math. Okay, but what you'd have to do is you'd have to factor out an x, do the quadratic formula, and what you end up with are 0 and then 3 plus or minus square root of 105 all over 4. Okay, so those are the places where it would cross the x-axis. Okay, intervals of increase and decrease. Well, okay, I know how to do that now. That's looking at the derivative, and so that's 6x squared minus 6x minus 12, right? And so to do that, it was easiest for me to find where it was 0 first and make a sign chart from there, right? So again, you can factor this, and we ended up finding that x is positive 2 and negative 1. Okay, so then with that I can make my sign chart. So there's f prime and f, right? And then I have to transition or look at the transition points of negative 1 and positive 2. And this is where I say, okay, in this interval, let's take a sample value. So f of minus 2, then I'm going to look at f prime of 0 and f prime of 3, right? And what I ended up getting was that this was negative, this was positive, and this was positive, okay? Meaning that I have increasing, decreasing, increasing, okay? So in terms of where it's increasing, I'm just going to say minus infinity to minus 1, and then 2 to infinity, and where it's decreasing, we have negative 1 to negative 1 to positive 2, okay? And so I'm just going to make a list of everything that it requires. Okay, maximum and minimum values. So I'm going to say that there's a local max at x is equal to negative 1 and a local min at x is equal to 2. And I'm just going to justify this by the first derivative test. Okay? All right, so then next I want to look at intervals of concavity. Concavity has to deal with the second derivative, which we found that to be 12x minus 6. Okay, and so then I can make a chart. We haven't done this yet, but I can make a chart like I did with my first derivative and say, okay, well, this is equal to 0, and so solving that, 1/2 is going to be where the second derivative is equal to 0. Okay, and in the same manner as before, I can take sample values from the from each interval here, substitute it in, and so I get positive on this side for the second derivative, negative on this side, meaning that this left side of 1/2 is going to be concave down, and the right side is going to be concave up. Okay, and then consequently the point of inflection is 1/2. So I'm just going to say concave down on minus infinity to 1/2, concave up on 1/2 to infinity, and then I'm just going to list my point of inflection I'm going to say at x is equal to 1/2. Okay, whew, I think I have everything. So now what I want to do is take all this information I've compiled, right, and put it into a graph. Okay, so my graph, I'm going to do it over here. So I know there's going to be some roots. There's going to be a root at 0, and then let's see, what are the other numbers I need to pay attention to? So there's negative 1, and that's really all I need in that side. Then there's 1, 2, I need to pay attention over there, and that's about it on that side. Okay, so what I know is, and if I evaluate this, actually I need to go out just a little bit more. What I end up getting is that I get a root there, a root about here, and then the positive version is about 3.5. Okay, so there are my roots. Okay, and I know it's increasing on negative infinity to -1, right? And then it stops. And then I have my maximum, right? And then I have a minimum down at -2, and it's decreasing in this region, and then stops, and then it increases thereafter. Okay, so now I just want to make sure that this has all the features that I need. So let's see, does it have the roots? Yes. Does it have the increasing and decreasing properties? Yes. Does it have the maximum at the specified value and min at the specified value? Yep. Does it look like x is equal to 1/2 is the point of inflection? Yep, pretty close. So I would say this is a relatively good sketch of the graph, okay, of that function. And that's all you're going to do on the values going, or on the other examples, okay? Generate this entire list of values, make a sketch, and make sure it has all the properties that you say it should.